Section 2.2 covers density curves and normal distributions. In this video, we are only going to look at the normal distribution piece of that. So normal distribution, probably something that you have seen before in other classes. It's this bell curve shape where we have the mean in the middle and we talk about how many standard deviations something is away from the mean. Okay, why is it important? Well, there's lots of data that just happens to fall into a normal curve. It shows up over and over again. Test scores, things in nature. It just shows up a lot. So it becomes very useful for calculating probabilities, which means that we can use it later in the year when we do what's called inference. And you'll see this coming up over and over and over again. So we want to get a real good grasp on the normal distribution and the normal curve. Okay, so something that is important to know about the normal curve, it follows this neat little pattern where 68% of observations or data values fall within one standard deviation of the mean. Okay, 95% fall within 2 standard deviations and 99.7 fall within 3 standard deviations. So we use this rule and these numbers a lot to do some estimates. So you're going to want to make sure that you memorize those 68, 95, 99.7, and that corresponds to 1, 2, and 3 standard deviations away from the mean. Okay. We'll talk about some other different types of distributions as well. So just make sure you note that this rule only applies to normal distributions, not any of the other ones we're going to look at. Okay, so one of the reasons we use the normal distribution so often is the probability. Yes, the probability of an event happening is equal to the area under the curve. Okay, so we can find probabilities if data is normally distributed. Okay, so here are our steps. We are going to draw the curve and shade the area that the problem is asking us to find. So we're always going to give ourselves a picture. We're going to perform calculations. There, you'll see there it talks about using table A or standardizing the values. And then the other option is to use technology, meaning a calculator without standardizing. That's the way that the method I'm going to show you in this video. And we can talk about table A, which is in your book and on your AP exam formula sheet. We can talk about that in class. And then the last part is be sure to answer the question that was asked. So we always need to have context. We can't just throw out random numbers without saying what those numbers mean. All right, so the example we're going to look at, the Iowa test is normally distributed with a mean of 6.84 and a standard deviation of 1.55. And we have information of 7th graders taking this test. What proportion of them have vocab scores that are below the 6th grade level? On this test, your score is equivalent to your grade level. So if they score a 6, that is a 6th grade level. If they score a 7, that is a 7th grade level. Okay, so step 1, we are going to draw the distribution. All right, we're going to draw the curve. So it's that same general shape every time. The mean is in the middle, 6.84. A standard deviation is 1.55. So going to the right, I'm going to add 1.55. And then going to the left, I'm going to subtract 1.55. We want to know what proportion are below 6th grade level. So 6 is going to be in here, somewhere between 5.29 and 6.84. And we want to know below, so that's why this area below 6 is shaded in. All right, for the next part, we're going to grab our calculators. And I have both a TI and a Casio here, so I'm going to show you how to do it on each one. Okay, on the Casio, we're going to go to the stat menu. So we're going to go to menu, stat, and we're looking at distribution, so F5. It is a normal distribution, F1, and we're going to do NCD. Okay, and so then it's going to ask us for some information. First thing I want to know is the lower limit. So if I go back to our picture here, all right, the lower limit, well, we don't really have one. I don't want to say it's 2.19 because the score could be lower than that. So generally what we use as a marker is 1,000. So if negative 1,000 if we don't have a lower limit, and positive 1,000 if we don't have an upper limit, okay? The upper limit in this case is 6, all right? We want to know everything that is below 6, and then we're going to put in our standard deviation and our mean from the problem. So the standard deviation on this test is 1.55. The mean is 6.84. All right, and then I go ahead and press execute one more time, and it gives me some information there. I'm going to get those numbers on the TI as well before we talk about what they mean. Okay, so on the TI, distribution is right here in blue, which means I need to hit second. So second distribution, and we want number 2, the normal CDF. All right, again, it asks us -1. We can leave what they put in there, -1 times 10 to the 99th power. That's good. All right, the upper limit is 6. The mean is 6.84. And the standard deviation is 1.55. All right, and then it pastes it in there, and then we press enter one more time. Okay, so TI 0.2939, and then on the Casio, you see the P equals 0.2939. That is the probability that one of these 7th graders scored below a 6th grade level at 0.2939. That is the probability. Okay, so if we go back to our question, we got our answer, and then the last thing we have to do is we have to be sure that we answer the question that was asked. So what proportion of 7th graders have vocab scores that are below a 6th grade level? All right, we had 0.2939 or 29.4%. Okay, and again, we just have to include that context. 29.4% is the answer that our calculator gave us. Include the context that it is Gary, Indiana 7th graders scoring below a 6th grade level on the vocab test. The other thing that we can do is we can work backwards. So if they give us an area or a percentage or a proportion, then we can find the value that is associated with that answer. So think about like our percentile questions and working backwards, okay? Same 3 steps: draw the curve, perform the calculations, and make sure our answer is in context, but the calculator steps are going to look a little bit different. So here's the question that we have. We know that heights of 3-year-old females are approximately normally distributed. They have a mean of 94.5 and a standard deviation of 4. 75% of 3-year-old girls are taller than what height? Okay, so we're essentially trying to find the 75th percentile here, okay? Or excuse me, really it would be the 25th percentile. So first step is draw our curve. Okay, so mean of 94.5, standard deviations of 4, so we added 4 and subtracted 4. We want to know what height 75% of girls are taller than. So I want to know what number here corresponds to this shaded in part having an area of 0.75. Okay, so the next thing is we're going to go to the calculators. All right, so on my Casio, I'm still in that distribution menu, still my normal distribution. Last time we did NCD, this time we're going to do INVN, or inverse normal, because we're working backwards. Okay, the first thing it wants to know is which direction is the tail. This is why we draw your picture. Which direction did you shade in the area that we're trying to find? All right, this one is to the right, so I'm going to choose left, right, center from the bottom, and I want to know the tail to the right. I want the tail to have an area of 0.75. I have a standard deviation of 4 and a mean of 94.5. Okay, and then when I press enter, the value that it gives me is 91.8. Let's see if we can get that same answer on our TI. So we're back to our distribution menu. So second distribution, inverse normal. Okay, for the TI, it always does the tail to the left. So if I want to know 75%, then the tail to the left is going to have an area of 25%. So the area that I'm going to put in here is 0.25. My mean is 94.5. My standard deviation is 4. Paste that, do the math. I get that same answer, 91.8. All right, so what does that number tell me? Okay, it tells me what this x value right here is equal to, and that is the height. All right, the height, that was what we're looking for. So what is this answer in? All right, the question asks 75% of 3-year-old girls are taller than what height? So we found that height, 91.8 centimeters. So our answer would be about 75% of 3-year-old girls are taller than 91.8 centimeters. Okay, so the answer in context does not have to be anything complicated, but just make sure that you read what the question is asking and that you answer it. And a complete sentence will put you in a better situation than just putting 91.8 and putting a box around it like it's an Algebra 1 answer. Okay, and that's it for normal curves.